This video will cover how to use Doric light sources with or without Doric Neuroscience Studio. In particular, we will quickly define the common ports found on our light sources, jump into using the standalone mode, then we will demonstrate how to expand the sequence capabilities using Doric Neuroscience Studio with the square, custom, and complex modes. Finally, we will cover how to add a camera channel to combine behavior and optogenetics together. Doric light sources include drivers for both LEDs and laser diodes, fiber light sources, which are integrated driver and light source devices, and the laser, which is an integrated light source that covers the entire spectrum required for optogenetics at high powers. The role of the light source driver is to send current from the light source port to modulate its light intensity, or for integrated fiber light sources, directly output light. Selecting the knob cycles through available standalone modes, such as CW, external TTL, and external analog. The continuous wave mode sends a continuous current to the light source, producing a steady light pulse at constant power. The silver knob on most drivers can be used to increase or decrease the current. The greater the current, the higher the output power. Next, two different external modes allow the light source to be controlled by other devices via the input port like a slave. The external TTL mode waits for a digital signal, a 0-1 or on and off, arising from the input port, and outputs the specified current only when the signal is 1 and no current when the signal is 0, effectively mirroring the pattern of the external source. The external analog mode is similar to the external TTL but waits for an analog signal, any voltage between 0 and 5, and outputs current proportional to the voltage value. Next, the output port generates a signal proportional to the current sent to the light source. Thus, both the input and output ports can be used to synchronize the light source during experiments. Finally, the USB port on the light source driver communicates with Doric Neuroscience Studio, expanding the available features and modes of the device. Once we open the software, we can create a configuration that can be saved and then reloaded later on. Select Add Channel to create a configuration from scratch. Here, the channel refers to the light source channel number on the device itself, and the mode selects between options available in standalone, in addition to new options like square, complex, and custom modes. We will cover each mode in greater detail later on in this video. Use the sliding bar to change the current delivered to the light source. Since the output power varies slightly between light sources, use a power meter to measure the relationship between current and milliwatts. Adjust the current according to experimental needs. A more direct way to set the light source excitation power is to use the optical power option, which is only available with the Pronto SI power meter. Here, we can specify the output power in milliwatts, then select Calibrate. Make sure to specify the excitation wavelength, 470 in this case, before starting the calibration. Note that a calibration is required every time the power is changed, but also when swapping optical components of the system, such as rotary joints and optic fibers, even when using the same target power. Next, the trigger options define what starts the stimulation sequence that we will create in the sequence options. By default, the manual type uses the record or live button to initiate the stimulation pattern, while the triggered and gated types requires a signal from the input port of the device originating from an external device. The trigger options differ from the simple external TTL mode covered in the earlier sections. While the external TTL mode simply mirrors the signal from the input port, the triggering options will start and stop the stimulation pattern specified in the sequence option, using either the triggered or gated types. The triggered type assumes the device is sending a short TTL pulse, while the gated mode requires a constant signal that terminates the sequence when no longer present. In addition, the triggered mode specifies how a sequence will be uninterrupted, paused, restarted, or continued. All the possible trigger option combinations for both triggered and gated options, including combinations with the repeatable sequence feature, are detailed in a separate video. To create different types of stimulation sequence, we will need to specify the sequence mode. The continuous wave, external TTL, and external analog were covered earlier and are identical to the standalone mode. The square mode creates a simple pattern of pulses at different rates, delays, and durations. Notably, each pulse will always be identical to the current power. In the sequence options, the starting delay sets the amount of time between the start signal and the first pulse. Next, we have the settings that affect every pulse and the settings that create a repeatable sequence. To specify the interval between two pulses, use either the frequency or the period. The frequency corresponds to the number of pulses that will occur within a single second, such that a frequency of 1 Hz outputs a single pulse per second, while 10 Hz outputs 10 pulses per second, independent of the pulse width. Alternatively, the period is the inverse of the frequency and specifies the duration in milliseconds between the start of the first pulse and the start of the following pulse. Then, to set the width of each pulse, either use the time on or the duty cycle. The time on specifies the pulse width in milliseconds, while the duty cycle uses a percentage of the period. The smoothing checkbox adds a ramping up and down option for each pulse. Selecting the Edit Edges button sets the rise time, plateau time, and fall time of the pulse. The active time is the summation of all 3 times and overrides time on or duty cycle. Once applied, the smooth edges will modify every pulse. Disabling this feature removes the angled edges. Specify the number of pulses within each sequence. If this number is 0, the pulses will run with the above settings for infinity or until stopped. You can also set the number of sequences that will run during the experiment and the delay between each sequence. The total duration displays how long the entire pattern of sequences will last, which is useful when the sequence goes beyond the preview. The complex mode changes several different sequences one after the other and provides a great flexibility for experimental designs. Use the plus button to add a sequence or a delay, and the negative button to remove the last addition. For each new addition, select the type of pulse, which includes previous modes such as CW and square, and new ones like triangle, ramp up, and ramp down. Finally, you can also specify a delay in milliseconds between each sequence. Notably, the current level of each sequence is customizable. The remainder of the settings are identical to the square sequence parameters and include starting delay, total duration, sequence-specific and pulse-specific parameters. Note that changing the related parameters such as time on and duty cycle automatically change the other, like so. Finally, the custom mode personalizes the pulse shape or sequence. Here, we can import a CSV file containing this personalized sequence. The file must be a single vector containing 1,000 data points between 0 and 1, where 1 corresponds to the current value no matter what it's set to. Values under 1 proportionally convert the current to lower values. For example, when the current is set to 1,000 milliamperes, 0.5 equals 500 milliamperes. Note that files with less than 1,000 data points will automatically fill in the missing data with values of 0, while files with greater than the required length will be cut off at 1,000 data points. Just like the other modes, we can specify a starting delay, period, which stretches or compresses the sequence in time, the number of sequences, and the delay between sequences. Selecting Add creates the channel. We can create as many channels as there are available light source ports on the device itself. We can also add a behavior component to the experiment by creating a Doric behavior camera channel. This functionality is available for both Doric behavior cameras in addition to most USB 3 web cameras. Use the ID to select between multiple identical cameras. Then specify the desired resolution and FPS. For the camera triggering options, non-Doric cameras can only be synchronized with the manual mode, which uses the computer's clock, while the Doric behavior cameras can be set in the external mode so that using a device like a BBC 300 can synchronize the optogenetic stimulation and behavior videos through a TTL pulse. The external mode provides a more precise synchronization compared to the manual mode. Select Add to create the camera channel. Here we can see the 2 channels that were created. On the left is the light source stimulation pattern, and on the right is our camera channel. To test your settings, select Start All Live, which will not save any data. To start an experiment, select Start All Record, which is only available when the camera channel is created, and will save your camera data. If you have any additional questions, please reach out to us at support@doriclenses.com.